Hi guys, let's take a look at this question. They tell us that the electronegativity of atoms may be used to explain the polarity of bonds. Define electronegativity. So just memorize your definitions, right? So electronegativity is a measure of the tendency of an atom in a molecule to attract bonding electrons. Then they want us to draw the Lewis diagram of oxygen difluoride. All right, so it's difluoride. So how are we going to draw this? We're going to have oxygen and then fluoride, and oxygen is going to share 2 electrons. So it's going to look something like that. 2.4. A polar bond, 2.3. Calculate the electronegativity difference between oxygen and fluorine in oxygen difluoride and predict the polarity of the bond. Okay. So 2.3, they want the difference in electronegativity of oxygen and fluorine. So we're going to take oxygen minus fluorine. So how do we get the electronegativity? We look at our periodic table, and you see on the side here, that is what we're going to look at for our electronegativity difference. All right. So we're going to take the highest, which is fluorine. So you can write it like this, or you can write it like that. It does not matter. That's just the difference. So it's going to be 4 minus 3,5, and that gives you 0,5. And they want us to predict the polarity. Okay, so our electronegativity difference, right, is going to be greater than 0, but it's less than 1. So what does that mean? That will mean that the bond is weakly polar. So the bond is weakly polar. 2.4. A polar bond does not always lead to a polar molecule. Explain the statement by referring to oxygen difluoride and carbon dioxide molecules in your explanation, and include the polarity of the bonds and the shape of the molecules. And they want 4 marks for that. So what on earth? What are we trying to say here? Okay, so between oxygen and fluorine and carbon and oxygen, the bonds in both molecules are polar, okay, because of the difference in electronegativity. Then we're going to talk about the shape. So the shape of the oxygen difluoride molecule is angular because the charge is asymmetrical, or the distribution of the charge is asymmetrical. And the shape of the carbon dioxide molecule will be linear because the distribution of the charge is symmetrical. And there we get your 4 marks. You talked about the polarity. Bonds are polar because of the electronegativity. And you talked about the shapes. 2.5. The diagram below shows the energy change that takes place when 2 atoms move toward each other. What does X represent and what does Y represent? So X here represents the bond's energy and Y represent the bond length. Define the concept represented by X. So what is bond energy? Bond energy is the energy needed to break 1 mole of its molecules into separate atoms. 2.5.3. Explain the relationship between bond order, bond length, and bond energy. The relationship between them. So the higher the bond order, all right, the shorter the bond length. And what happens to the energy? The stronger the bond. So that means the bond energy will increase. Okay. And that is it, guys. See ya.